Guess what?
What?
This Saturday is the solstice!
That's right, Saturday, June 20th is the solstice, sometime in the late afternoon or early evening, depending on which time zone you're in. It's very exciting. So that means it's the first day of summer in the northern hemisphere, and it's the first day of winter in the southern hemisphere. Wait, what now? That's right, solstices mark the first day of summer and the first day of winter, depending on which hemisphere you're in. Let's take a minute to explain why this is the case. All right, first, let's address this misconception. Well, it's summer in the northern hemisphere because the Earth is closer to the sun in June, right?
Wrong!
The truth is, change in season isn't related to Earth's distance from the sun. In fact, the Earth is closest to the sun in January, known as perihelion, and it's at its farthest point from the sun in July, aphelion. So it's kind of like opposite of what you think it would be. That's because Earth's orbit around the sun isn't a perfect circle. It's an ellipse, which is like a circle but less round. See? All right, change in season is related to Earth's position relative to the sun and Earth's axial tilt. Fun fact, all of the planets in the solar system are tilted on their axis. Some are tilted a little bit, like Mercury, which is less than 1%, so it sits practically straight up and down, and some a lot, like Uranus, which is nearly 98%.
Uranus.
The Earth has an axial tilt of 23.5 degrees. Here's why that's important when it comes to the seasons. All right, something you should know. As Earth moves around the sun, its axis always points in the same direction, as you can see in these pictures. So it doesn't wobble or flop around or anything like that. It always points in the same direction. Okay, now because of this tilt, certain parts of the Earth receive direct sunlight and others receive indirect sunlight, like in the picture below. So if we're looking at this picture, look, here's the cursor. If the arrows are close together like this, it means that you're getting more direct sunlight. If the arrows are farther apart, it means you're getting less direct sunlight. So this is where it's going to be warmer, and this is where it's going to be cooler. If I'm looking at this picture, what it means is this. Notice how the axis of the northern hemisphere is kind of tilted away from the sun, and the axis of the southern hemisphere is actually kind of tilted towards the sun. What that means is the southern hemisphere is getting more direct sunlight, and the northern hemisphere is getting less direct sunlight. In other words, the sunlight is kind of stretched out. Allow me to explain a little further. All right, let's take a minute and let's try to demonstrate the idea of direct versus indirect sunlight and intensity, because that's what it's all about. If we are going to have summer in the northern hemisphere on Saturday, and we are because Saturday is the solstice, it means that the northern hemisphere is getting more direct sunlight, and the southern hemisphere, in which it will be winter starting on Saturday, will be getting more indirect sunlight. So let's use a carefully crafted visual aid to help sort of explain that. This is what I'm talking about. Now, you remember the picture that I showed you earlier with those arrows that were much closer together. That signifies that you're getting more direct sunlight. So let's demonstrate that. It's like if I take some mustard and I put it on a piece of bread like so. In the northern hemisphere on Saturday, what that means is that the sunlight is direct, and therefore it's very intense. Intense enough so that if I were to eat this bread, I would be getting all of the sun's energy all at once. Kind of like what we're going to do on Saturday, because we're going to be getting more direct sunlight. Ew. Oh. It's gross! Ew. Sorry, that's disgusting. Do not try this at home. Ew. Alright. Now, on the other hand, the southern hemisphere, in which it will be winter starting on Saturday, it's a little different. Because what happens is, instead of piling all of that energy in one place like what's happening in the northern hemisphere, because the northern hemisphere is tilted towards the sun and getting more direct energy, the southern hemisphere is actually tilted away from the sun. So essentially what happens is that natural tilt makes the sun less direct. And so essentially what it does is it kind of spreads the mustard out over a much larger area. So then when you take a bite, it's less intense. It's the same thing with the sunlight. That sun's energy is much less intense in the southern hemisphere, so that's why they'll be having winter. In December, it will be kind of the opposite. We'll be in a different position in our orbit, And as a result of that, our axis will be pointed away. We'll be getting the indirect energy, and the southern hemisphere will be getting the direct energy. So in other words, right now, we're getting all the mustard. The southern hemisphere is getting that nice spread out mustard. In the winter, we'll get the spread out mustard, and the southern hemisphere will be getting the big pile of mustard. I hope that makes sense. All right, I'm going to stop eating this mustard on bread because it's gross. Okay, let's go back to this picture. Remember, like I said earlier, seasons depend on two factors: position and axial tilt. This is what I'm talking about in terms of position. So like I just said in the video, here we are right now at approximately June 22nd or June 20th or June 21st. It varies depending on the year. In this picture, the axis of the northern hemisphere is pointed towards the sun, so we actually are having summer in the northern hemisphere because it's receiving that direct sunlight from the sun. Because the southern axis is pointed away from the sun, we're getting indirect energy, and therefore it's going into winter. A few months later, as Earth revolves around the sun, we're in a little bit different position. Now the northern hemisphere axis is pointed away from the sun, and the southern hemisphere axis is pointed towards the sun. So it's opposite. It's winter up here, and it's summer down there.